Assalamualaikum warahmatullahi wabarakatuh. A very good day to all. So today we're going to look at the lab on Projectile. So this is part of again the B2121 lab. And one of the lab experiments that we need to do is basically the projectile motion. So we're going to look at the apparatus of the projectile motion in a bit detail. And I'm going to explain a bit in terms of the theory and what are the variables that need to be changed in it. So this is the projectile motion equipment, where if you look at from the top here, then you can see this particular cylinder, and inside it you have a spring. So as I push, so we have a ball, like a ping pong ball over here. So as you push it in, then basically you're going to compress the spring, right? The compressor spring. So there are three levels of spring compressions that's available for this particular experiment, and we're going to compress it at three different locations, and then we're going to put a latch on it, and we're going to release it so that the potential energy from the spring will be transferred to the ball, and the ball will float from here, and then you can see a projectile in motion, right? So that's one of the variables that we're going to change in this particular experiment, which is the compression of the spring, right? The second thing that we're going to do is change in this experiment is this angle. So if you look at from the side view here, so we have the angle and the angle indicator in here. So we're going to vary the angle at three different levels, if I'm mistaken. And basically at that particular angle, then we're going to launch the ball at a specific spring compression position. And basically because of that, then basically the ball will travel at different distances. Stop. So right now the spring is being compressed, so the latch is holding it. So you actually have energy stored in the spring, right? So you can actually calculate the energy of the spring by certain equation, if you remember. So energy compressed potential energy of a spring is equal to 1/2 of the compressions times the K, which is the spring constant. But for this particular experiment, it's given to you. So remember, the first catch position is 1 joule, second catch position is 1.5 joules, and the third catch position is 2 joules. 2.5. 2.5 joules. So let me repeat that again. So the first catch position is 1.0 joules, second catch position is 1.5 joules, and the third catch position is 2.5 joules, right? So that information is very important for you for this particular lab, because then basically having that knowledge, then if I release the latch and if the spring is fully uncompressed, right, at that particular point, then the spring potential energy is equals to 0, and all the energy is actually being transferred to the ball. So the ball will travel with the same energy as the initial spring compression energy, right? So with that, then basically you can do equation, the equation of the conservation of energy from potential energy to the kinetic energy, and you can actually find answer to the initial velocity by calculations using that principle. And for this particular case, we're going to adjust the compressions at three different levels, as I mentioned just now: first catch position, second catch position, and third catch position. Okay, that's about the catch position adjustment for this particular apparatus. Alright, so the second setting that we're going to change in this launcher, basically the angle, the launch angle. So the launch angle can be adjusted by unlocking the clamp and then moving it outwards, and this particular indicator will indicate what are the angle. And we're going to adjust the angle from 10 to 70 degrees increment of 10. And launch the ball accordingly. So there'll be a combination of different latch position and different launching angle, and based on that, then we're going to measure the distance from this point to where it's going to land. The ball is going to land, and that distance is called S. That distance is called S. So as I mentioned just now, there are two variables that we're going to change in our experiment. One is the catch position, which correspond to different potential energy of the spring compression. The second variable that we're going to adjust is the angle, the launch angle, right? And there are a few fixed variables in this particular experiment. One of it is basically the height of the launcher itself, and the height of this launcher is being measured from the floor up to that particular point, and this point corresponds to the outlet of that particular launcher itself, right? So we have to measure that distance. So and this is important as a part of the calculation, because at that particular point, then you know what's the potential energy of the ball at this particular point. The other variables that we're going to that's going to be fixed for this particular case is basically the ball itself. So all the experiment will be done on the same ball, and the weight of this ball, the mass of this ball is 10 grams. The mass of this ball is 10 grams. So basically, once the latch position is set, once the angle is set, then the ball is inserted into the launcher. We pull the trigger, and the ball will travel. The ball will travel, and we landed at certain distance in front. Then basically we're going to measure that distance from this particular location to where the balls landed, and that distance is called S. Demonstrate to you how this experiment is going to be conducted with one particular setting. So in this particular setting, in this particular experiment that I'm going to demonstrate, I'm going to put the launch angle at 30. So what I do is I'm going to adjust the angle of this launcher until that indicator hit at 30, and then I'm going to lock this position. Right? So that's how we set the angle. Right? Second thing that we need to do is basically we're going to set the catch position to setting number 1, which corresponds to 1.0 joule. So let's do that. So the way to do it is you push the ball down until hit catch position, until hit that latch position, and I'm going to put the latch in. So right now is catch position 1, and angle is at 30. So basically, if I lift this trigger, then you're going to see the ball travel in that direction, in this direction. And basically, if you look at on the floor, we have a tape. Yeah? So we're going to measure the distance where the ball actually hit the floor, and that distance is called S. This distance is called S. So I'm going to release the latch now, and you can see how the ball travels. 1, 2, 3. So as you can see, the ball traveled and we indicate where it landed. So we're going to measure the distance from the projectile from the launcher to that particular distance, and that distance is called S. So with that, you have one set of data. You have catch position 1, you have launch angle at 30 degrees, and you have distance S, as shown by the 10. And we're going to repeat this experiment to complete the combinations of angles and catch positions.